Hi, my name is Paul Spywasser. I'm here with Greg Wright. We chose to do our topic on next-gen air traffic control. In our introduction section, we will discuss some of the background of the air traffic control field and will first describe to you the next-gen technology that has been the focal point of our research report. In the history section, as you can imagine, we will be going into the background of the air traffic field. In the technology section, we will break down the different systems and ideas that work together to create the next gen technology. And we will be able to share the benefits that all of these systems can create while working together. In the future section, we will discuss the problems that could come from the creation and implementation of the next gen technology. And finally, in our conclusion, we will wrap up everything we have discussed through our presentation and deliver our final opinion of the next gen technology. Our introduction. Air traffic for the majority has been the same for the past 60 years without getting an upgrade in its system of tracking airplanes traveling across the United States. That does not seem like that should be how things are done. When in contrast, most all other technology has been updated in some dramatic way over that time. Thanks to the new innovative technology that's being pushed forward by the Obama administration, soon pilots will no longer have to go out of their way to stay within the radar of the next aircraft control tower. Soon planes progress will be able to be followed through the use of GPS-like technology known as Next-Gen Air Traffic Transportation System, or Next-Gen for short. The airlines will save billions of dollars over time on saved jet fuel that they won't have to use because the airplanes will be able to take the more direct routes to their destinations. Also, with the saved money the airlines will have from using less fuel, customers that are taking their flights will be able to anticipate a lower cost in airplane ticket prices. This picture is taken in the 1930s of one of the original air traffic control rooms. In the history of air traffic control was not always seen as an essential safety parameter for air flight in the United States. In the early 1900s, there were so few planes being flown around that it was not a tremendous worry that these planes would crash into each other and therefore did not need help in avoiding each other. The first form of air traffic control began in the late 1920s and consisted of men going out into open fields and waving flags so as to communicate with pilots flying overhead. This was primitive, however, and not very reliable, so in 1930, the first radio-equipped control tower in the United States began operating at the Cleveland Municipal Airport. By 1932, almost all aircrafts were equipped with radio communications equipment, and by 1935, there were about 20 radio control towers in operation around the United States. As the number of flights increased, so did the need for air traffic control that could communicate between each other and to other cities. And therefore, in 1935, the first Airway Traffic Control Center opened at Newark, New Jersey. And in 1936, Chicago and Cleveland created their own centers. During wartime needs, women were also trained to become air traffic controllers, and at their peak, represented at least 40% of the air traffic controller workforce in America. By 1952, the CAA had begun its first routine use of radar for approach and departure control, and a few years later they placed a large order for long-distance radars for en route air traffic control. In 1960, the Federal Aviation Administration, or the FAA, began testing a system under which flights in certain positive control areas were required to carry a radar beacon called a transponder, which identified the aircraft and helped to improve radar performance. This allowed controllers to reduce the distance between airplanes in half. In 1970, the FAA established a central flow control facility to prevent clusters of congestion from disrupting the nationwide air traffic flow. In 1994, the concept of free flight was introduced. This allowed pilots to use onboard instruments and electronics to maintain a safe distance between planes and to reduce their reliance on ground controllers. For this concept to work, it would require the use of GPS tracking systems, which brings us to where we are today with the new proposed idea for next generation air transportation system, or NextGen.
The new next-gen air traffic control system will have several different technologies working together to make the system a success. For the better understanding of how these systems work, it would be helpful to look at the systems again and highlight some of the technologies that the system will use and explain why they are better than the current technology. To begin, the new technology will take advantage of an integrated flight planning system, which will allow operators and traffic managers to have immediate access to identical weather information through one data source. Enhanced surface traffic operations will allow pilots and controllers to talk less by radio. Data communications expedite clearances and reduces communication errors. This technological advancement will reduce the workloads among both pilots and controllers. NextGen will also implement a streamlined departure management system where area navigation and required navigational performance precision allow the multiple departure paths from each runway. With this new technology, departure capacity will be increased. Planes will also be able to have more efficient crews because RNAV, RMP, and reduced vertical separation minimum utilize reduced separation requirements, increasing airspace capacity. ADSB, or Automatic Dependent Surveillance Broadcast supported routes, will be available to equipped aircraft. By January 2020, the majority of aircraft operation in the United States will need to be equipped with ADSB, which will allow pilots real-time tracking capabilities of every aircraft equipped with the technology. ADSB will constantly update pilots on weather conditions, terrain information, and even other planes' velocity, altitude, and heading. NextGen will also use the new technology referred to as streamlined arrival management, which will be an arrival sequence that is planned hundreds of miles in advance to the landing. Enhanced surface traffic management will also be used in the arrival process for planes using next-gen air traffic control technology. Runway exit points, assigned gate numbers, and taxi routes will be sent by data communication to pilots miles before they approach the airport. Of course, one could not talk about the technology aspect of the next-gen technology without mentioning the main premise behind it, the utilization of a GPS, or Global Positioning System. GPS is a space-based satellite navigational system that provides location and time information in all weather anywhere on or near the Earth. This is a picture of one of the ABSDs that will be used in the airplanes and will help with the guiding of the plane on a more direct and faster route. Leading challenge of the future. The main challenge that NextGen is facing right now is the installation of ADSB into every aircraft operating in the U.S. airspace. At this point, it's very expensive to buy and install an ADSB into an airplane. It was estimated by the FAA that it would cost anywhere between $1.2 to $4.5 billion to implement ADSB in each plane by 2032. If NextGen is to be successful, the FAA needs to find a way to reduce the cost of implementing ADSB technology into planes or find a new technology altogether. NextGen also faces the problem of implementing its technologies on time. It is a very time-consuming process to do a wide-scale implementation of the NextGen needs for it to be operated. Not only does the FAA need to install its technologies into every airport in the U.S., but also install it into every airplane. Another possible problem that will emerge from NextGen in the future is the ever-increasing air traffic. One of the reasons NextGen is being implemented is because of the large amount of air traffic today, but what happens when it becomes too much for NextGen to handle? The only answer to this question is that FAA must constantly upgrade NextGen once it is up and running so that the technology continues to run smoothly. The FAA should also be looking out for innovative technologies that could help the NextGen be more successful. As stated earlier, new technologies could speed up the implementation process or reduce implementation costs. As long as the FAA constantly looks out for possible problems and possible opportunities, they should be able to ensure the successful implementation of the NextGen. This is a possible issue with the NextGen technology, and it demonstrates how congested the screens can be on the monitoring the planes while they fly overhead to their desired destinations. In conclusion, NextGen is a cool new technology that should be put into use as soon as possible. Advancing from a technology where men would go out into a field and try and wave flags in a certain pattern so as to inform pilots in the air of other planes to a technology run by GPS where only limited communication would be needed, even in the large amount of air traffic, is amazing. The advantages of the new GPS-like technology is a positive for all parties that are involved, whether that be the big airline companies saving money on fuel purchases or the customers who will be arriving at their destinations in a shorter amount of time and paying less for ticket prices due to airline companies needing to spend less on fuel for their planes. Obviously, as with any new technology, installing the next gen into all active airplane cockpits will cost a good amount of money, but we can hope that the overall good can be seen and the end result will be more money for everyone involved. You have to spend money to make money, and this is a surefire way to make money. Thank you for listening. Have a nice day.